The topic for today is automated sample storage and is it worth it? And really this is a way of evaluating for your own setting whether automated storage is right for you and your samples. During this presentation, I'm going to give a brief introduction to SPT Labtech and then really focus on the reasons why, or maybe even why not to automate. During this, we'll look at a cost comparison model comparing automated to manual storage, and then also some approaches that consider semi-automation as an approach. And then finally, a little look at implementation considerations, and then to draw some conclusions. SPT Labtech are a UK-based company, and we manufacture robust, reliable, and easy-to-use solutions for sample management, cryo-electron microscopy, and liquid handling for drug discovery. Our aim is to enable life science through collaboration with our customers to develop new and innovative solutions, and pretty much every product that we supply today was born through a customer-based collaboration. So we're very keen to continue to work that way and collaborate and innovate. In terms of our storage systems, we have two basic families of product. So we have the compound product range, which the original models of these were launched in the early 2000s. So they've really been around a while now, and they're well proven as robust and reliable systems. These operate at -20. We have options for +4 and also room temperature. And then more recently, in the last 5 or 6 years, we introduced the Arctic range, originally at -80, and now we also have -20 options. And both of these actually offer very high density storage for 2D barcoded tubes and offer random access to samples through true cherry picking of samples that are required, and use a unique pneumatic transport system. So I'm just going to give you a little flavor of that now so you know what we're talking about. Firstly, the compound system. Samples are entered into the system in a standard rack. The tubes are taken in and individually sucked up through the pneumatic system. The barcode is read, and then there's a number of pathways that they can be sent down to a final storage location in one of these storage carousels. So there's a unique location for each tube. There's also a transport system within that carousel that enables a chimney for transport to form between the carousels. So we can quickly access any tube by simply rotating one carousel and then using the pneumatics, which means we can deliver a full rack of 96 samples in less than 10 minutes. We also have accessories like the com stacker, which allows greater walk away. So you can have up to 15 racks to load in or to unload to. So the users can walk away, leaving it to run through a series of orders. And then we also have the option to actually send samples remotely through the pneumatics. So we can actually send samples outside of the store. So a system could be in one location in a building, and it can send through a pneumatic pipe through the building to a remote delivery location. In a similar way, in the Arctic system, we also use pneumatics, and there's a similar input-output zone. The difference here is that there is a purging system to ensure we remove any moisture from the samples, particularly when we're going into a -80 store. That's extremely important. And then the samples are taken through the pneumatics, the barcode scanned. And here, with the challenges of -80, we have a slightly different approach where we stack tubes on top of each other in aluminium pipes. And then we actually can retrieve the samples by first moving the samples we don't want out of the way to get to the sample that we do want, and then deliver that. We've recently extended the Arctic range to include an extension of capacity and also the ability to remote deliver, similar to what I showed in compound. So we call this Arctic XC, and the idea is that customers can start perhaps with a single storage device, and then as their capacity grows, they can add additional systems over time. These can be interconnected and can also benefit from remote delivery as well. So you'll see in a moment that these systems can deliver to a benchtop box called the Connect AC, which allows input and output of the samples. Again, this can be in a different location. So what that enables are some workflow benefits. So for example, if you're processing blood samples and perhaps making aliquots, DNA, serum, RNA, plasma, and so on. From the processing lab, you can have one of these remote stations, and you can send directly after processing samples straight to the biobank, which could be in a completely different part of the building. So the benefit there is really the speed at which you can get samples straight after processing into the biobank, rather than having to wait for batches and then perhaps taking them down on trolleys to the biobank at some point later in the day. They can go straight from processing straight to the biobank, and thereby optimize the time taken, or minimize the time taken even. So why do people automate? Well, there's a whole host of reasons. And you see many of them listed here, such as quality, the accuracy and repeatability, ability to integrate, traceability, speed, time. There's a whole host of reasons. And they're quite individual depending on the setting, and the priorities of different customers are different, and the nuance of kind of each customer's reasons will be different. Conversely, if you look at why people don't automate, often a big barrier is actually the cost. So if you look at the 10-year costs of a fully serviced automated system, you're realistically looking at around about $500,000 and upwards, and even up to $5 million and beyond, depending on the size of the system. And this is typically 5 to 10 times more expensive than a manual approach. If you look purely at the cost of the manual storage systems, the freezers, and also the upkeep and maintenance of those. And then you also have to manage that change. Moving from an existing manual process to an automated process may not be so straightforward and will require quite a lot of management. So these are quite significant barriers at times to automation. But there are other factors to consider. And I think sometimes it's too easy just to compare the basic cost of an automated system against the cost of manual freezers. You do need to consider carefully other costs, and I think in particular the labour costs, so that the cost of the people actually picking samples and who spend a considerable time doing that can be quite high. The energy costs of running many freezers can be high, and the space required for those freezers. So those are generally quite easy to assess. What's much harder to assess is the value that comes with better sample integrity, greater ease of sample accessibility, and better data integrity and security. And it can be much more difficult to actually put a dollar value to those. So we've done a justification case study that we'll go through in some detail now. And what we generally consider as the kind of for automation is the convenience, space, security, the traceability, benefits in energy savings, and speed and efficiency and time. And against, as I've already mentioned, things like the initial cost, ongoing service costs, and so on. So we did a comparison for 100,000 samples, which would require one of our Arctic systems. The equivalent in manual freezers would be 3 manual freezers, and generally most customers would have a 4th freezer for redundancy. In case a freezer failed, they could move them across. The automated store already has a redundancy system in there that has the equivalent of that 4th freezer as backup. We then did a data collection. So we did a kind of timing study with one of our customers, and we observed them order picking. And the initial findings from that were that already that their store was 10% fragmented. If you look on the picture on the right, you'll see that their tray with dry ice and the racks they're picking from, and you can see that the holes, kind of the purple colors of the holes in there. And it's about 10% fragmented already, and that will increase over time as they pick more samples from that. This is a very highly organized system that they've got, a freezer farm of about 50 freezers, and we observed the average pick time for them during a picking session was about 26 seconds. And that includes some time to set up the tray with the dry ice and also some time for manual data entry. So this is the basic number that we used in the calculations that follow. But I will stress that this is a highly organized system. Many customers that I speak to often quote 2 to 3 minutes and more per sample when they're collecting. So it really does need to be tailored to each individual setting. We also looked at electricity consumption, and I'll go into a little bit more detail about that. So what did we do next? Well, we looked at the cost of the freezers and the service. We looked at the labor costs, the electricity costs, and then we tried to make some consideration of what I would call the intangible costs, the things that it's harder to put a dollar value to. And when we looked at those initial cost considerations, for an automated store, so for the Arctic system, for the 100,000 samples, for 10 years, fully serviced, the electricity and all the running costs and so on, it came out at around about $675,000. The equivalent with the manual freezers was about $120,000 for cost and service, but then you need to factor in the labor costs and the electricity costs. In terms of electricity costs, that can get quite complicated because for a manual freezer, every time you open the door, you get a spike in power. And what we did here was we did a 1 hour picking session. And what we saw was you get a spike for about 3 hours where the power rating goes up to about 1.7 kilowatts. And then for a further 2 hours at about 1.4 kilowatts. And then finally it drops down to its passive 1.1 kilowatts. So the more you go into the freezer, the harder it works, the more electricity it uses, which kind of makes sense. With the automated storage system, because we're moving vials through a pneumatic tube, there's almost no difference between when it's picking and when it's not. So you get this, the Arctic runs pretty much at this equivalent passive power here, about 1.1 kilowatts, and no spikes as you pick. So we did a cost comparison with the manual picking, and we looked at the picking labor costs, the electricity costs, and then the capital and service. And we looked at a number of picks per week. So from 100 sample picks per week to 500 picks per week to 1,000 picks per week. And what we saw, the capital and service cost doesn't change because you've got the same numbers of freezers. The picking labor cost goes up dramatically as you increase the number of picks per week. And then the electricity cost also goes up a little bit as you increase the number of picks because of those door opening events that I mentioned. So you come up with these totals over 10 years. And that's still a little bit shy of the automated cost at 1,000 picks per week, but it's getting close. So from this one, you'd say that anyone picking kind of more than 1,000 samples per week could probably start to justify moving to an automated approach such as the Arctic. Now, this approach assumes that you are very tidy with no defragmentation. And what that means is that picking labor also includes time to go back and actually replace samples that you've picked, and therefore not needing new freezers as you start to run out of space. And that's not how it tends to work. Some people do defragmentation, maybe not so often. So the complete opposite end of the scale would be what I would call the untidy model. And that is where you never fill a space that you've picked. And every time you run out of space, you buy a new freezer. So we then mapped that over 10 years. And 100 picks a week, you run out of freezer space after about 5 years and you need a new freezer. But as you ramp up to 1,000 picks per week, you rapidly run out of space. And over a 10-year period, you would go from 3 freezers in use to 14 freezers required. And then obviously you might need additional backup freezers as well. So this can get quite expensive quite quickly. If you then put that through the calculation, you see that at 1,000 picks per week, you're now more expensive than the automated approach. So actually it comes in somewhere around about 800 picks per week. Now, in reality, most customers are somewhere between those two models. Most defragment once in a while and don't end up in this complete extreme of runaway freezer requirements. But most will have increasing fragmentation over time. So the reality does kind of lie somewhere between these two. So we would say somewhere between 500 and 1,000 picks per week is a good case for automation with this simple sort of calculation. But it may be that you do that calculation for your own setting and find that it isn't quite so favorable and that there is an extra cost. So you then maybe need to consider, are there reasons why you might be willing to pay more? So one of the key things is sample integrity. You know, everybody understands that you need good samples to do good research. And we did some work on the issues around sample integrity. So first of all, if you consider samples going into a freezer, we put samples in a rack in a freezer quite commonly, and everybody expects, yeah, they're going to freeze, they're all going to be the same, they're all in the same rack. But actually they all get treated quite differently because of their position in the rack. So we did some tests where we put thermocouples in different positions in tubes with buffer in them, and we monitored the temperature profiles over time. And unsurprisingly, I guess, the samples in the middle take a lot longer to reach sub-zero temperatures. So it's like over an hour for the samples to go sub-zero and 70 minutes to reach -40. So there's quite a difference between how those samples are being treated. Then we looked at the opposite when coming back out. So most customers pick samples on dry ice. And again, thermocouples in different positions, a rack purely sitting on dry ice, and we monitored the temperature. And I think there's a real false sense of security with dry ice. People assume that it's being kept at -80 when it really isn't. And you can see in the worst case scenario here, within 15 minutes, the samples around the edges were around -38, a long way from the -80 that customers are probably presuming. So that there is quite a significant difference in the manual use of samples in racks when you compare that to a system where the tubes are going into individual storage locations and each tube is being treated the same. So that in itself may be a strong argument for a different approach. We also looked at freezers themselves and the positions in freezers. So this diagram shows where we place thermocouples. The grid in the center with the dots is kind of a bird's eye view from above, so that the purple dot is actually right at the front of the freezer in the middle of the freezer. And we monitored that over time of continual door opening over an hour picking session, so in and out of the freezer during an hour. And quite surprisingly, even though the freezer never registered a temperature worse than -70, the front position near the door was actually around about -55. And actually, we stopped this test after an hour. Really should have carried on to see when that would plateau. I suspect we would have approached -50. So innocent samples that you never pick are seeing temperature deviations either in the freezer as you're opening the door or in the rack as you're doing sample picking. And that's just something that you're not going to see in an automated system, and thereby, greater protection of the samples and greater sample integrity. So think about other things that might justify the cost. We've talked about sample integrity. What about lost samples? What about the ones that you can't find that have been moved from the freezer by accident or have just gone? How do you put a cost on that? What about lost space? Some places can put a cost on space. If you are taking many meters of space for freezers, you might have a cost per meter squared for your unit, your organization. You may not, but that's something you can consider. And then as the number of freezers grows, they generate more heat. That puts more strain on the freezers. They tend to break more quickly. And then you might need to invest in extra site things like air conditioning and so on. So there are many kind of knock-on effects of more freezers that need to be considered. So the case study conclusion was that for this case study, around about 1,000 picks per well can justify per week rather can justify automation, and above 500 picks per week may be worth it if you're willing to pay perhaps a little bit more per sample to actually look at the other benefits that you get from that. The sort of things that we've looked at, I think, provides a good model for capturing the main costs, and it's a way of modeling the cost per sample. And in fact, if you do some simple division of the samples processed per year against the cost that I've shown there, you can bring that out straight to a cost per sample, which can also be a useful number to look at. So can you justify that extra cost per sample is ultimately a question that needs to be answered, and whether you can then take that to directors at your organization to actually justify the spend on automation. A few other things just to look at. So when customers are looking at manual versus automated, it's often a case of one or the other. And we've gone through some of the benefits of the automated route. So in things like time saving, efficiency, more organized, connection to limbs we haven't mentioned, but that's another important one. And then also we talked a little about the sticking with what you know. So it might be history, it's flexible, you know what you're doing with it, it's low cost, and it's very much in a comfort zone. But actually, it doesn't have to be one or the other. And I'm just going to give you a short example of a customer that now actually uses both very effectively. So we've worked with the MRC epidemiology unit in Cambridge, and they collect samples from a range of field clinics. When they get those samples, they process them immediately and they aliquot them. And what you see, the rack in the middle of the screen here is a single patient collection where they get multiples of things like plasma heparin, plasma fluoride, plasma EDTA, serum, and urine. And there's multiple aliquots of each represented by different colors in this case. What they then do is they go to the central lab in Cambridge and they're put in a freezer, and then once a week or so, one of the technicians will actually condense those samples into a single rack and then into a manual freezer. And then when they want samples from that, somebody has to take the time to go and pick individual samples. So hopefully that's a workflow that many of you are familiar with. They wanted to change that because the problem was the time taken to pick large numbers of samples for research. So if they wanted a whole cohort collection and they've got 35,000 patients on this study, it would take literally months to do that last part and pick the samples. So they changed and they introduced the Arctic. And what they now do is the samples go directly on reception straight into the Arctic. Every few weeks, they run pick orders, and what they do is they organize them into sample types. So in the center of the screen here, you see these different colored racks, each one representing a different sample type of 96 different patient samples. And that means that when they get a full cohort request for, let's say, serum samples, they can just pick whole racks from the manual freezers of serum samples. It also means that they can spread those samples across many different manual freezers, thereby reducing the risk of losing a full patient set if a freezer goes down. And what they also do, they keep one aliquot of each sample type actually in the Arctic. So if they get specific requests from a customer just for particular samples, they can just pick them automatically at the Arctic. So it's a really good example of working with a mix of automation and manual to kind of minimize the cost, but maximize the efficiency. So robots and people can coexist, and I think that that example gives a really good way that can be used. And we've actually got an application note specifically on that, so you can get that and download it from our website. So final part of the presentation is really just a few thoughts about implementation. So how long will it actually take to implement an automated solution? And presentations I've been to over the years have typically seen this at 2 to 3 years for large automated systems, just because of the maybe building works required, the complexity of install, building the workflow around it, and so on. So do you need to do that? Is there another way? Can you look at where automation could impact your workflow the best? Or does it need to be the whole workflow? And I think if you can pick off parts of the workflow that would best benefit, you can really minimize that time. Will you need infrastructure changes? Will you need to knock walls down? Will you need to change things? And how will you manage that transition? From our perspective, we've purposely gone with kind of smaller solutions to minimize those infrastructure changes. And typically we can install a system within about a week. Now, that doesn't mean that it takes a week to do this implementation, because you may have limbs, you may have how it affects other parts of your workflow. So while the automated solution may be in and working within a week, it may take longer to do the work around it, but at least that part of it can be kept quite short. You also need to consider the staff. Have they got enough time? Do you need extra hires? Will there be a period where you need to reduce your service to your customers? And then overall, what are the depreciation costs and what the expected working lifetime for the system? Because at some point during the use of that system, you're going to have to start thinking beyond what you do, once it's reached the end of its working life. So I would close with a few conclusions, and the first part of that is that I think trying to do this evaluation, a good approach is to try and build a cost comparison table. So these are sorts of things that you could consider. We've talked about the purchase costs, the service costs, looking at depreciation, the labor costs, and that's going to be one of the big ones, the power and services costs, and then also the costs associated with implementation. And on the right-hand side, I've indicated where you're likely to see cost savings with automation and where you're not. And really, the big wins with automation tend to be reduction of labor cost, allowing your people to actually get on with some science rather than spending their time with heads buried in freezers, and also in the power and services costs and also the space costs. So this sort of approach can really get a good grip of what is going to cost you the current approach versus the new automated approach, and allow you to make a decision and decide whether it's right for you. And it may not always be favorable for automation. Of course, a company like ours hopes it will be, but it's right that you do this type of approach. We are about to launch a return on investment calculator, and you'll all be mailed this in the subsequent mailings from this meeting. And that will allow you to enter just a few bits of data and get an assessment of whether automation could be right for you. That is only kind of a top level look at this, and we are able to do much more in-depth calculations and work with you on that. So if you would like to do that sort of thing and get us to help you, then please contact us and we'd be more than happy to assist you with that. So final conclusion, can you build a comprehensive cost model in the way that I've discussed during this call? Does automation fit your workflow and throughput based on that assessment? Could you partially automate, and would that make more sense? And do you have a solid implementation plan? And finally, having contingency plans for when there are bumps in the road during that implementation, I think, is another important factor. So automation can bring huge benefits, but it does need careful consideration and extensive planning.